Hello and welcome back to the AKS Cost Management Series. Today we are discussing how AKS scalers can help you improve your resource utilization and optimize your AKS clusters to be more cost efficient. Today, joined with me are Amanda Wang and Wilson Darko, fellow PMs on the AKS team. Welcome. So excited to have you and be discussing this topic with you today. To start, Amanda, Wilson, how about we learn a little bit about what you do here on the AKS team?
Yeah, I can get it started. Thanks, Casey. My name is Amanda Wang. I'm a PM on the AKS team. I work on AKS Automatic, add-ons, some of the cost work streams, as well as application scalers, which we'll talk a little bit more about today.
Word. And yeah, thanks for having me. My name is Wilson, and I work on compute, in particular on the scale side, particularly infrastructure scalers, such as Node Auto Provision and Carpenter, as well as Cluster Autoscaler.
Amazing. And before we deep dive into some of our AKS autoscalers, I want to talk a little bit about what the concepts of over-provisioning and under-provisioning are. So over-provisioning is really when the capacity, there is excess capacity, resource wastage, or your applications are using less than what they're actually requesting for from a CPU and memory perspective. And on the flip side, under-provisioning is when there aren't enough resources requested for what your application needs, which can lead to issues like throttling or kills, which can be really problematic from a performance perspective. So how do AKS autoscalers fit into a user's optimization strategy? Amanda, can you tell us a little bit about some of our AKS application scalers and how those work?
Yeah, definitely. So let's start and think about how Kubernetes handles scalings and why it matters. Like Casey mentioned, we don't want the cluster to over-provision as well as under-provision, which can lead into issues. So in Kubernetes, there are two main types of scalers, application scalers and infrastructure scalers. Application scalers focus on your workloads, which are the pods running your applications. They use metrics like CPU usage or custom signals to decide when to scale up or down, help you maintain performance without over-provisioning resources. These scalers operate at the pod level, adjusting either the number of replicas or the resource limits for each pod. And when we talk about application scaling, we're really talking about two dimensions: horizontal scaling, which is adding or removing pod replicas, and vertical scaling, which is adjusting the CPU and memory allocated to each pod. Next, we'll take a closer look at three key application scalers: VPA, HPA, and KEDA, what they do, when to use them, and how they can help you run your apps more efficiently on AKS.
Sounds good. Let's deep dive into it.
When you deploy a new app to Kubernetes, one of the first things you have to do is to define its resource requirements, CPU, memory, and so on. But let's be honest, most of us just copy-paste values from another app and hope for the best. The problem? These guesses pile up across deployments, and over time, the gap between what your app actually uses and what it's been allocated can lead to wasted resources, or worse, performance issues and higher costs. That's where the Vertical Pod Autoscaler, or VPA, comes in. VPA automatically adjusts your pod's CPU and memory requests based on historical usage. It helps right-size your workloads, scaling up when needed and scaling down when possible, to keep your cluster efficient and your app stable. VPA supports multiple modes. In recommendation-only modes like initial or off, it suggests optimal values without enforcing them. These modes can be enabled during testing, and VPO recommendation values can then be used to set the CPU and memory requests and limits for production environments. In auto or recreate mode, it can apply changes dynamically on the fly, although that might involve restarting pods. If that's a concern, you can try using a pod disruption budget to control how and when those restarts happen. Ultimately, VPA helps you reduce waste, improve performance, and free up resources for other workloads, making your AKS cluster more cost-effective. Now let's talk about the Horizontal Pod Autoscaler, or HPA. HPA is one of the most commonly used application scalers in Kubernetes. It automatically adjusts the number of pod replicas in a deployment based on observed metrics, typically CPU or memory utilization. For example, if your app starts getting more traffic and CPU usage spikes, HPA will scale out by adding more pods to handle the load. And when demand drops, it scales back in to save resources. It's important to know that HPA works at the pod level, not the node level. So while it helps your app scale horizontally, it doesn't directly manage the underlying infrastructure. That's where infrastructure scalers like the cluster autoscaler or node auto provisioning come in. Now let's look at KEDA, Kubernetes Event-Driven Autoscaler. KEDA extends the capabilities of HPA by enabling event-based scaling. Instead of just reacting to CPU or memory metrics, KEDA can scale your application based on external event sources, like messages in a queue, events in Azure Event Hub, or metrics from Prometheus. It supports over 70 built-in scalers out of the box, including Azure Monitor, cron job, and many more. This makes it ideal for event-driven architectures or bursty workloads where traditional metrics don't tell the full story. One of the coolest features of KEDA is that it can scale your app down to zero when there's no activity, saving you on compute cost. And when an event comes in, it spins the pods back up automatically. Also to note, KEDA is a managed add-on in AKS. This means we take care of the operational overheads such as CVE patching and version upgrades, so you can focus on your application logic. Next, Wilson will talk more about infrastructure scalers.
Okay, so Amanda kind of spoke about the different open source projects that we leverage and some of the managed add-on experiences at the application scaling level. But also there's a need if you have enough pods that become unscheduled that you will need to scale up the number of virtual machines or nodes as we refer to it. So in this case, we use two types of infrascalers, cluster autoscaler, which has been our kind of tried and true scaling method for some time, and node auto provisioning, which leverages the open source project Carpenter to provide even more kind of opportunities versus cluster autoscaler. So first, I'll speak on the experience for cluster autoscaler, where in this case, cluster autoscaler uses existing node pools or groups of nodes and just increases the amount of same size VMs that exist in that based off of the pending pod pressure that comes in, and then also the utilization within those pods, within those nodes. So if it needs to scale up or down, it'll leverage that information to do that. But essentially, it pretty much uses the same type of nodes within those node pools. So while you can increase the amount of compute utilization, you may want to get a bit more granular. And to that case, that's where we now introduce our kind of new development, which would be node auto provisioning, which is our managed add-on experience for the open source project Carpenter, as I mentioned before. What's slightly different about Carpenter versus the cluster autoscaler experience is that it's able to more tightly bin pack your pods into essentially whatever VMs that might be needed. In the scenario of cluster autoscaler, you essentially have to know the exact SKUs or VM sizes that you might leverage, whereas with Carpenter and Node Auto Provision, you could essentially just give the general information you might need to the system, and it will schedule the relevant single instance VMs for your system. So you have a much more variety in this case, and there's so many benefits in this case from a cost standpoint and several others that we'll speak to in more detail. But to that point, let's actually explore the experiences between cluster autoscaler and node auto provisioning in this case. So as you can see here, this is kind of what that experience looks like between the two. As I mentioned, you're essentially using node pools or groups of nodes in the cluster autoscaler scenario, and that has to be pre-existing node pools that you would then scale up or scale down. Whereas for node auto provisioning, it essentially does the provisioning as well for single instance VMs, whichever amounts you might need. And in both scenarios, you can leverage spot or on-demand resources, but essentially with node auto provisioning, you can have those in the same kind of groupings versus for cluster autoscaler, that might be slightly different there. So again, the bin packing opportunity for both, but I would say in particular, node auto provisioning is pretty exciting. So that is essentially our infrastructure experience. And with that, we can kind of explore the combinations of these different scalers when we pair them together.
Yes, that was an amazing overview of all of our AKS scalars and really hitting on the concept of bin packing, why it's so important to think about app scaling. And then naturally, once your pods are right size and effectively scaling, then thinking about the infrastructure piece and how your pods can pack onto the right size SKUs that are, of different costs. So yeah, let's take a look at combining some of our scalars. How common is it for customers to use a mix of app scalars and/or app plus infrastructure scalars? And what are some of these safe combinations that customers should be exploring? Amanda, do you want to take that?
Yeah, definitely. So as we can see in the table, there's quite a lot of different combinations based off of existing scalars that we have talked about previously. Generally, it's really highly recommended to use HPA with one of the infrastructure autoscalers, but not recommended to mix HPA with another application scalar like VPA. And because KEDA is also built on top of HPA, it's generally not recommended to use KEDA with VPA as well. This is because both of these application scalars scale based on the same metrics, generally CPU. So when both of them are reacting to the same metric, they can make different scaling decisions. So for example, if VPA increases the CPU request, HPA might see that as a lower utilization and then scale down. So then that can have some conflicting impact. And then Wilson, do you want to speak more to how NAP can be utilized with some of the application scalars?
For sure. So, as kind of shown in the table here, it's really recommended if you're leveraging one of the infrastructure scalars, we strongly recommend using NAP in this case, as it has kind of better bin packing opportunities compared to cluster autoscaler. And similar to what Amanda mentioned, just making sure that you're not overlapping the application scalars in the wrong manners, particularly VPA. And if you are going to leverage VPA, then you can put that in recommendation mode or passive mode to kind of avoid that negative feedback loop, if you would. But to that point, no bias here, but just a strong recommendation to leverage node auto provision for your infrastructure needs, and then kind of the world's your oyster in terms of the application level options that we've highlighted here.
And Wilson, earlier you mentioned that cluster autoscaler was, one of the original infrastructure scalars for now node auto provision. Can you share more about why they can't be used together on the same cluster at the same time, and why the customer needs to make the decision to pick one or the other?
For sure. So in a similar manner to the application scalars where they might use the same information for their scaling choices, the same can happen at the infra level. So for cluster autoscaler and NAP, sometimes if you're using both in the same cluster, it becomes hard to distinguish what is driving what scaling action, right? So to that extent, for our purposes, we strongly recommend using node auto provision for your infrastructure scaling needs. You do have the option since we offer Carpenter in two different modes, the managed add-on, which is NAP, which we've been talking about, and also the self-hosted version, if you want to have kind of more granular control for your system. You can technically use self-hosted Carpenter and cluster autoscaler in your cluster, but as I mentioned, we just strongly recommend leveraging the managed experience, which is a much more simplified and streamlined effort for these needs. So to that extent, I hope that answers your question.
Yeah, that absolutely does. And one more question on how do I leverage these autoscalers without causing disruptions to my workloads? Say I have like a stateful application and my cluster is scaling. How can I ensure that my pods don't have any downtime as they're getting scaled up or moved to different nodes of different SKU types?
So in this case, you would leverage what Amanda referenced earlier, which would be pod disruption budgets, which kind of ensure that your system is not dealing with the unscheduled or the unnecessary disruption that you wouldn't want. In addition to that, you can leverage, let's say for upgrades, you can leverage maintenance windows for node auto provision to ensure that any disruption, whether intentional or based off of scaling happens when you want it to take place. So that would be kind of the main method. In addition to that, for node auto provision, you can use the node pool file or config file to really set the parameters of when you want things to happen and how.
And what are some of those other configurations that I can set within the node pool definition? Is there any flexibility around certain SKUs, or if I have reserved instances, for example, how do I define that in the node pool definition?
Yeah. So in the node pool definition file, you would essentially be able to kind of highlight if you want on-demand or spot instances in your system. You can also leverage multiple architectures as well. So really a lot of different options there, even to the point of the types of SKUs that you might leverage, GPU, CPU, otherwise. The world is your oyster, as I said before. So in this case, you should be able to do with boundaries, of course, the big ticket items that you want to address.
Amazing. And that would apply just to the infrastructure level, right? I could use any of these application scalers alongside my cluster that has RIs and savings plans as well.
Yes, that should be the case.
Amazing.
Yeah, with NAP, you can, like Wilson mentioned, you can specify exact SKUs that you might have as part of the savings plan. And then you can still combine NAP with application scalers. For example, if you use NAP alongside of KEDA, KEDA can still honor specific events that maybe your applications is listening on, and use those events as methods for scaling the pods. And then NAP would be used to kind of bin pack better for the nodes, and to ensure sort of the best cost savings as well as performance for your application.
And one more question about kind of the GPU scenario plus the app and infrastructure scaling. GPUs are much more costly than CPUs, and they're a lot harder to secure just because they're a lot scarcer than CPUs. So how can these scalers help me run my GPU and AI workload in a cost-effective way?
Well, in the case of, let's say, at the infra level, if you are finding any underutilized aspects of your GPUs, cluster autoscaler and particularly NAP would be able to really optimize that bin packing experience so that you're not keeping pretty much underutilized GPUs, which, as you mentioned, can be a bit costly. And we can leverage kind of other tools in there as well, be that KEDA, what have you, for your system to get the best results.
And to kind of wrap up this discussion, are there any other call to actions, places that customers can continue to learn about all these amazing AKS scalers? What would you both recommend?
Yeah, I would just recommend trying it out in a developer environment and seeing kind of how different scalars work individually, and then trying different combinations. And it's really pretty much customizable based on your environments and your needs for scaling as well. If you have sort of more stable workloads that doesn't really get a lot of burst traffics, you can get away with sort of doing less scaling. But if you have workloads that sort of have more event-driven workloads, then could recommend KEDA. And then for everybody, we pretty much would recommend NAP for better bin packing for your environment. And yes, but give it a shot, and also take a look at our documentations. And if you have any feedback as well, feel free to open up an issue on the AKS GitHub.
Sounds good. Wilson, any last bits?
Yeah, and kind of to the point about testing things out, check out Chaos Studio. You can definitely kind of experiment, either testing out what happens when an event takes place for your cluster and how would the different scalars react. We'll also have some demos available as well, in addition to workshops in terms of Carpenter, KEDA, and others. And I believe we actually have some videos on our YouTube page that kind of speaks to these experiences as well. So feel free to check those out.
Absolutely. Well, thank you both so much for all the insights. And yeah, hopefully this video, an overview of all of the AKS scalars was helpful to those who are watching. So thank you both so much.
Sure.
Yeah,
Thank
thank
you again.
you.